Hello, my name is Nadia, and today I'm going to show you how to use the Grove MQ-2 gas sensor with the Raspberry Pi to detect different gases. So before we get into how we're actually going to be using this gas sensor, I'm going to go over the technical specifications and a bit of background about this device. The first thing you need to know is that it has an operating voltage of 5 volts, analog and digital output from 0 to 5 volts, a preheat duration of 20 seconds, and it can be used as analog or digital. As you can see over here, the device has a potentiometer. It's either on the top or bottom depending on the specific one that you get, and this can be used to adjust the sensitivity of the sensor to various gases. It also has a comparator op amp over here, two LEDs, this one's for power, and as you can see it only has 4 pins. The first one is VCC, ground, and then one for digital output and another for analog. So as you can see here, the sensor has two layers of a fine stainless steel mesh known as the anti-explosion network, and this serves just to protect the filter and the sensing element on the inside of the gas sensor, since we are using it to detect flammable materials. And it has this clamp ring over here just to secure the mesh in place. Once this is removed, it looks something more like this. So this is the sensing element on the inside, which has 6 legs connected to the following pins. And this is what the sensing element looks like on the inside. So the most important thing to know is the coating of tin dioxide. So the MQ-2 gas sensor is a metal oxide semiconductor type gas sensor, mainly used to detect gases such as methane, butane, propane, LPG, smoke, carbon monoxide, and alcohol. It's known as a chemiresistor because the gas detection is based on the principle of change in resistance of the sensing material when the gas comes in contact. It consists of this sensing element here, which is made of the metal oxide semiconductor materials such as tin dioxide, which has a high surface area and is sensitive to changes in the concentration of different gases. So when a gas is detected, the MQ-2 sensor's internal resistance changes, which in turn changes the voltage across its output pins. And this change in voltage can be measured by a Raspberry Pi. This graphic on the left does a really cool job of simplifying how the chemistry behind the principles of this gas sensor work, and the graphic on the right just shows how the concentration of gas in the air is translated into an output voltage. So both of these graphics and the pictures on the previous slide were from Last Minute Engineers. They do a really good job of explaining this if you're interested. So what you'll need to try this out is of course a Raspberry Pi and a gas sensor, as well as a analog to digital converter. For this I'm using the MCP-3008 chip. You'll also need a breadboard, some jumper wires, and it would be helpful to have the Raspberry Pi ribbon cable and GPIO breakout expansion, which just makes it easier when you're trying to connect things. However, if you just have a bunch of male to female jumper wires, you could do without it. So this is what my setup looks like over here. I'll be showing you how to hook up the hardware in a second. As you can see over here, the gas sensor that I have doesn't have pins coming outwards. Instead, it comes with this connector over here, which I didn't know about when I was purchasing it. So instead, I just ended up putting my jumper wires into the connector. But make sure to buy the one with the actual pins because you can just put it into your breadboard then and it'll be much easier to use. Over here is how you're going to want to hook up your components. So as you can see here, this is the pinout for the Raspberry Pi, and this is the pinout for the MCP-3008 chip. First, you're going to want to hook up pin 24 of the Raspberry Pi, which is this one over here. As you can see, it's the pink wire, to the chip select pin, so pin 10 of the MCP chip. Next, you're going to hook up the GPIO 9 and 10, so the SPI MISO and MOSI of the Raspberry Pi, to the D out and D in pins of the MCP chip. So that's this purple and brown wire over here, as you can see. So this is for pin 19 and 21, so these two over here. Next, you're going to hook up GPIO 11, which is the SPIO S clock of the Raspberry Pi, to the clock pin of the MCP chip. So that's this orange wire over here, and that is going to be pin 23 over here. Last, you have the two voltages that you're just going to hook up to 5 volts, and that's a VDD and your VREF over here, and your ground pin goes to ground. Over here we get to the gas sensor. So like we said, the gas sensor has 4 pins, ground, voltage, D out, and A out. So first off, you're going to hook up the D out over here to GPIO 26 of the Raspberry Pi. So that's pin 37 over here. And you're going to connect your analog output to the MCP chip. So that's channel 0. And then you're going to hook your ground and voltage to ground and voltage. This is the code that I use to interface my gas sensor with the Raspberry Pi. You're going to need to import rpi.gpio in order to be able to manipulate the GPIO pins of the Raspberry Pi. As you see here, we're going to set the mode as gpio.bcm, which allows us to specify which pin numbering system we're going to be using. And over here, I just have these pins defined as constants. So remember, we connected our SPI clock to GPIO 11, SPI MISO to GPIO 9, SPI MOSI to GPIO 10, and the chip select to GPIO 8. So this Python function over here just reads the SPI data from the MCP chip and returns it as a digital output. And over here we have our main loop. So we have a sleep for 10 seconds here, just to let the gas sensor start up. According to the technical specifications, this should be 20 seconds. But just for the purpose of speeding this up, I have this for 10 seconds. So here we're reading the gas level using our function up there, and we're getting the air quality in a range from 0 to 5. So here we have a set threshold of 1.5 volts. If the air quality measurement that we get is higher than that, then we detect a gas leakage. Otherwise, our gas is not leaking. And here we're just printing the value that we're getting, and we're doing that every 5 seconds. And here's our main function. So now I'm going to try to show you guys how this works. So first you run the script, and while it's waiting for 10 seconds, I have a candle over here that I'm going to use to detect the smoke once it's blown out. And I also have some perfume to be able to detect some alcohol. So you start with the candle, it's blown out, and then as you can see, the gas sensor can detect that smoke. So once we move this away, the gas sensor levels go back to normal again. Just waiting a bit for the smoke to clear up. Okay, and now with some perfume, you can see I'm just going to spray this over here, and it can detect that as a gas leakage as well. And then it'll take some time for that to go back down again to normal level. So that was how to use the Grove MQ-2 gas sensor with the Raspberry Pi. I hope this was a bit of a helpful explanation, and I'll try to leave as many resources as I can as links in the description.